Nice to meet you.
Nice to see you. So where you position now, in Jakarta or somewhere?
Excuse me?
Mr. Lee, you in Jakarta or in Seoul?
In Seoul.
In Seoul, okay. Yeah, good. So this afternoon, I understand that your company Hyundai also involved in the nuclear plant. A surprise for me. Very surprised.
Yeah.
Because so far we understand that the Hyundai is an automobile in Jakarta.
Yeah, there are a lot of automobile car in Jakarta made by Hyundai.
Pak Jarod udah dapat itunya Pak, papernya sudah boleh mau dia kasih.
Dia ada copyright yang saya nggak bisa ini jadi PDF Pak.
Oh ya.
Nanti saya rubah ya setelah acara ini.
Ya dirayu aja. Hilang dia.
Pak Israel, gimana kabar?
Prof, terima kasih Prof undangannya Prof. Alhamdulillah kabar baik.
Kayaknya ini loh, saya ngeliat foto-fotonya main golf di mana-mana nih, Pak.
Alhamdulillah mengisi waktu pensiun Prof. Sambil nunggu PLTN jadi.
Oh. Ini moga-moga dalam waktu dekat sudah ada pengumuman PLTN.
Yang belum pernah muncul itu Cak Hadi loh Pak.
Apa namanya? Misterius.
Misterius.
Ini sudah
misterius.
Ada Pak.
Ada, tapi orangnya nggak pernah kelihatan.
Tapi kalau kita butuh referensi pustaka selalu punya.
Oh ya siap. Luar biasa itu. Dan kebetulan yang butuh image di bidang kedokteran itu ponakan saya.
Oh.
S2-nya kan itu tentang begitu-gituan. Jadi ngirim ke saya bingung. Saya kirim ke dia aja.
Gimana Pak Susilo?
Ya, selamat sore Pak Jarod.
Nggak ke Jogja, lama nggak ke Jogja nih?
Iya, lama nggak ke Jogja ya, udah kepengen tapi ada acara terus. Pak Markus ngajak rapat lagi.
Ketua, apa kabar Pak Ketua? Sehat?
Alhamdulillah, atas doa restu Bapak.
Doa semua ya Pak, semua anggota mendoakan ketuanya sehat selalu.
Pak Utama ini gambarnya sorghum ini, pejuang sorghum Indonesia.
Barusan diskusi soal sorghum.
Oh.
Belum pindah sorghum memang. Jadi topik today, dan jangan sampai jadi euforia.
Thank you.
Now you are using the laptop wider now, Dr. Lee, the display. So how is the South Korean situation on the nuclear energy program? The presidents of the South Korea support the nuclear, Dr. Lee?
Yeah, you know the new president.
But the previous president, he didn't.
Before president is anti-nuclear, so new president fully support nuclear power plant in Korea. Also, the export SMR to the other country.
But anyway, it's good to have the
How
new
about
president.
you? How about
I think our Indonesian president, he support the nuclear energy, but maybe it still need time to declare go nuclear. Maybe he has to discuss, negotiate with other politicians inside the country. But I expect in the near future, in 1 or 2 years, there will be a declaration go nuclear from the leader of the country. But unfortunately, 2 years from now, we will have general election, including presidential election. So it's very busy with the politics. There are many people, expert on the reactor technology, participate in this webinar. I see Dr. Dandang, he's the expert on reactor technology, and some other participants also. Hopefully he will ask you many questions.
I'm nervous,
Okay.
So, Dr. Diana?
Yes, just call me Jarrod.
You mean the Jarrod?
Yes.
Jarrod? Some in PPT there is some movie. In the YouTube link in movie. So I will ask some part, and in order to play the movie. In the case in the case you, I think some you use and some option about to hear the movie voice.
Okay. Okay. Maybe I would like to ask Mr. Rifki here from Hyundai Engineering Jakarta. Maybe you can search in YouTube the movie about the micro modular reactor as asked by Dr. Lee.
Is the movie?
Movie from my side, actually.
Later on, maybe.
Okay.
Because it's already 4 p.m. I have to begin the webinars.
Okay. We can start. Okay.
Okay. I will first use the Indonesian language, but later we will continue to use the English. Selamat sore Bapak Ibu sekalian. Saya akan memute dulu semua peserta kecuali yang diminta untuk berbicara. Hari ini kita memasuki webinar ke-43 di tahun 2022. Kita mengambil topik kembali ke nuklir setelah 2 kali kita webinar keluar dari nuklir, tapi itu bagian dari kami mempromosikan berbagai teknologi di Indonesia. Kali ini kita mengundang Hyundai Engineering Company Limited. Mungkin bagi Bapak Ibu sekalian mengenali Hyundai itu kendaraan roda 4 misalnya, mobil, meskipun sebenarnya banyak hasil dari Hyundai. Dan kita mengundang Dr. Lee Sang-il, seorang engineer, head engineer, nuclear engineers dari Hyundai yang mempunyai suatu teknologi Hyundai tersebut yang disebut reaktor modular mikro. Ini membingungkan sebenarnya bagi teman-teman awam. Ada SMR, ada mikroreaktor, ada reaktor besar dan lain sebagainya. Biasanya ada pembagian. Kalau reaktor yang besar itu 300 megawatt ke atas, antara 20 atau 50, kadang ada 20 sampai 50 megawatt sampai 300 itu small modular reactor, yang di bawah itu adalah mikroreaktor. Mikroreaktor mulai populer juga karena bisa lebih fleksibel penggunaan, bahkan ada beberapa teknologi yang bisa diangkut. Saya akan menggunakan bahasa Inggris sebagai pengantar webinar ini, tapi Bapak Ibu silahkan kalau mau bertanya di chat dengan bahasa Indonesia, nanti kami translate ke dalam bahasa Inggris. Apa saja boleh ditanyakan. Good afternoon, ladies and gentlemen, that we have a webinar, Indonesian Nuclear Society webinar, the 43 webinars. So this year we already conducted many webinars with various topics, nuclear technology, nuclear engineering, nuclear reactors, and also others related technology in Indonesia. And we invited several figures from domestic expert and also from foreign expert to explain the nuclear technology and other related technology also. And today we have a special guest, Dr. Lee Sang-il. He is the head nuclear engineers of the Nuclear Engineering Company Limited, Hyundai Engineering Limited. He will explain about microreactors, not only microreactor, micro modular reactor, and generation 4. This is very important, generation 4. But before that, I would like to ask Dr. Susilo Widodo, the chairman of BRIN, to give the opening remarks. Please, Pak Susilo. I can't hear you. Oh, sorry. I have to make you the co-host. Please, Pak Susilo.
Oke, apakah bisa terdengar suara saya?
Bisa.
Terima kasih Pak Jarod atas kesempatannya. But make a small correction. I am not the head of the chairman of BRIN, but chairman.
Oh, sorry.
Too high from me.
Maybe someday.
Okay. Let me speak in Indonesia because I speak in English a little bit tired to speak in English. Bapak-Bapak Ibu sekalian, Assalamualaikum warahmatullahi wabarakatuh. Selamat sore, salam sejahtera untuk kita semua. Marilah pertama-tama kita panjatkan puji syukur kehadirat Tuhan Yang Maha Esa, Allah SWT, yang atas rahmat dan kenikmatan yang diberikan kepada kita semua. Sore ini untuk kesekian kalinya kita bisa bertemu kembali dalam acara webinar HIMNI, Himpunan Masyarakat Nuclear Indonesia, yang kesekian kalinya. Pak Jarod tadi menyebut yang ke-43 kalinya. Ini hampir setiap minggu ada webinar ini, kita syukuri bersama dan mudah-mudahan untuk kali ini pun bisa memberikan tambahan pengetahuan, tambahan wawasan kepada Bapak Ibu sekalian yang memang dengan setia telah mengikuti webinar ini sejak awal. Saya lihat memang kali ini pesertanya memang agak berbeda, banyak tokoh yang hadir, Pak Dandang, ada Pak Isro, dari ini Mr. Wiratmoko Setiaji, selamat datang, dan yang lain-lain yang tidak mungkin kami sebut satu demi satu. Saya tidak panjang lebar karena kesempatan ini mungkin lebih baik kita berikan kepada our distinguished speaker, Dr. Lee Sang-il, our distinguished speaker. Welcome to this webinar, and thank you very much for your time, to spend time to give us some explanation, some presentation about modular reactor, especially what you call micro generation reactor. It will be very interesting for us because you know that we are struggling to get the first unit of nuclear power plant, but so far we are still have no any operation of any nuclear power plant, and therefore, as we are Indonesia consists of small islands, we have 17,000 islands, and then my eyes of course will turn to every effort to introduce a modular system, which most likely will be suitable for small modular to generate electricity in every islands in Indonesia in future. And thank you very much. That's Hyundai Engineering Company would also propose this kind of reactor, and yes, we are waiting for your presentation, and hopefully that will be met our need in Indonesia. So, thank you very much, and saya kembalikan kepada Pak Jarod. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Oh, well, I have made mistakes. Dr. Susilo Widodo is not the chairman of BRIN, but chairman of Indonesian Nuclear Society. Sorry, Pak Susilo, but maybe someday you will be the chairman of BRIN. Okay. I will show you the short video of the Indonesian Nuclear Society.
Yes, good.
Well, let's continue with the webinar. So, Dr. Susilo Widodo mentioned about the nuclear energy in Indonesia. Maybe, as you know, that we have a roadmap of net zero emission. According to Ministry of Energy and Mineral Resources, that Indonesia will operate the first nuclear power plant around 2040s. It's mean maybe 2045 or maybe 49. There are some difference timetable for that, but at least the government already declared that 2040s there will be 5 gigawatt NPP. 5 gigawatt NPP means everything. Although comparing with the total energy in Indonesia, the demand maybe it's very small. But for us, for the nuclear community, it means everything. For example, 5 gigawatt. What is the meaning of 5 gigawatt in 2040s? If we use the large reactors, 100 or more megawatt, it's mean maybe 4 NPP. But if we use small modular reactor, maybe it needs more than that, more than 4. But for example, if we use in some small island or in some industries, use the microreactor with the power around 20 megawatt, for example, it needs much numbers of the nuclear power plant. So this is very interesting. While the around the world also we see that some countries they are constructing the nuclear power in Bangladesh, in Uni Emirate, and in Turkey, for example. Even the latest news is that Poland will build the new nuclear power plant. The first contract for the Westinghouse will build that, and the second, the South Korean company. And today, we will hear the explanation of the Hyundai Engineering Technology. The Hyundai Engineering Technology, maybe some of you don't know about Hyundai Engineering Company Limited. But we would like to hear explanation from Dr. Lee about that, the explanation about the micro modular reactors. And I will shortly introduce the CV of our biography of Dr. Lee. Dr. Lee is younger than me because
thank you.
I was born in 1963. Dr. Lee was born in 1965, 2 years younger than me. His current position is Chief Engineer and Education. The PhD is coming from the Nuclear Engineering of the Korea Advanced Institute of Science and Technology, KAIST, and Masters from the same universities, the Korean Advanced Institute of Science and Technology, and the bachelor's coming from the Department of Nuclear Engineering, Seoul National University. He has many experience in foreign countries. He have a joint project with the United States, and for the employment record from 1997 to 2009, he worked for the Capco Engineering and Construction Company. But in 2010, he's working at the moment for Hyundai Engineering Company Limited. So this is very interesting. So we would like to hear your explanation, Dr. Lee. So maybe some participants, their background is not the nuclear engineers or not familiar with the technical term of nuclear. Maybe their question is general for some time, but some of the participants here is also expert. So I invite them also to ask Dr. Lee many things about this technology. And someday, maybe this microreactor will be built in Indonesia. So please, Dr. Lee, the time is yours.
Thank you, Dr. Jerome. Nice to meet you and Indonesian and nuclear society and the experts. So I appreciate inviting me for make a presentation about the micro modular reactor, and also I appreciate in future and give me a chance to explain the micro modular reactor technology. Also, I hope and you can get more information also in future. I wanted to make collaborations with Indonesia Nuclear Society for the deployment of micro modular reactor in your country. So okay, so please, so open.
Okay. Yeah, I will share on the screen. Okay. Wait. Where is this? Is it okay, Dr. Lee?
No, so
you cannot see my. Please wait.
Yeah, I can see the list of mail list.
Pak Susilo juga nggak bisa ngeliat ya?
I see only the folder of your.
Oh, okay. Wait, why? Okay, wait. You can see this one?
Not yet.
Yeah, now.
Yeah.
Okay.
Please change mode for the presentation.
Why? Why I cannot the full screen? Please wait, because sometimes we have difficulties. I have to close first the presentation, your presentation, and I will open it again. Wait. Is it okay? Not yet?
Yeah, no. It's yeah, okay. Okay, okay, not the full screen. However, I can.
Sorry, I have a trouble with my computer. Please.
Okay, may I start?
Oh.
I think you use the slideshow.
Okay, I have clicked the slideshow, but I cannot change into full screen.
Yes, slideshow. You can the menu upon.
Okay. Wait.
Yeah, good. Thank you.
Oh yeah. Okay.
Yeah.
Okay, please.
Yeah. Okay. May I start? Okay. Thank you very much. Thank you, Gerald. Okay.
Please.
May I start?
Yeah, please.
Yeah. Hi everyone. My name is Sang Lee. I am already Dr. Gerald explained my career. I am in charge of the head of nuclear office in Hyundai Engineering. The title of my presentation today and the development of post generation micro modular reactor and by Hyundai Engineering. So please next. Okay, so I think this slide is about the global energy trend. So I think the participant is export energy or nuclear. So that's why you know the current situation. And due to climate change, and growing demand for no greenhouse gas such as carbon dioxide. The many countries wanted to reduce the emission of carbon dioxide. They introduced the carbon tax. This graph showed the Canada federal carbon tax rate, and the current 2020 and 2022 current carbon tax is about the $50 per ton. However, and in the 2030, the carbon tax is expected to increase to the 178. So, okay, may I? I'm not sure. Okay, next. And this slide show about the status of MMR, the developed, and many countries are trying to develop SMR because the technology, the SMR is more economic, more and advanced than the current nuclear power plant based on the water reactor. So, and there are about the 17 the SMR is under developed. So the table show the status of the many SMR developing status. Some and like MMR, also new scale, the PWX 300 and okay, 100 also, and the so many and the reactor. Some I would like to say the MMR, the status, the MMR status. The MMR will be deployed in the 20 and 26. I expect some also, and I think this table showed the MMR is post generation reactor, which expected in deploying in the in the Western the area, including the some and the Canada and the US and Europe, also in the Asia area. And how about next? Yeah, this table should explain about the SMR reactor type, and the shortly, the SMR type consists of this kind of four categorized. And one is light water reactor. Light water reactor based on the current commercial big nuclear power plant. Also a heavy water reactor. Some heavy water reactor based on technology based on we call the CANDU, the heavy water reactor developed by Canada engineering company, we called AECL. And the next, the high temperature gas cooled reactor. So, and this reactor based, this use and helium as a coolant. That's why we call high temperature gas cooled reactor. And the next, sodium paste reactor, and finally molten salt reactor. And I think high temperature gas cooled reactor and the sodium paste reactor, molten salt reactor, we call the post generation. And the post generation means And the characteristic for generation is that the very higher the safety and the very higher safety and the grade function than the current light water reactor. So it means there is no the severe accidents such as Fukushima and the Chernobyl accident. And the next. Yeah, this slide showed the short introduce of a high temperature gas cooled reactor. And the left hand figure show, and we call the PW pressurized water reactor, large reactor. And also, in comparison of PWR, we call the pressure water reactor and high temperature gas cooled reactor. And also first item coolant. In the PWR use water, however, the HTGR is helium, and the moderator, the PWR use water, and HTGR use graphite. And the core coolant temperature of PWR is about 320 degrees C. However, our temperature of HTGR is more higher temperature, and such as higher than and 750. Also, we call the very high temperature gas cooled reactor can produce the 950 degrees C. And the reason is that high temperature gas cooled reactor produce very high steam. Is used as helium as coolant. That's why we call the high temperature gas cooled reactor. And the core temperature of a high temperature gas cooled reactor is lower than and the PWR, and the pure type. We call and the TRISO. High temperature gas cooled using TRISO. I can explain more detail at the next slide. Also, and no, please. Yeah, and high temperature the application of high temperature gas cooled the reactor is more the multiple the purpose because and due to high temperature steam, and this high temperature steam produced by and HTGR is used to produce the hydrogen and provide the process heat chemical plant, and also electricity, also industrial heat application. And please next. Yeah, this slide shows the history high temperature gas cooled reactor. In the 1970, we called the gas cooled reactor, using the carbon dioxide. This kind of reactor was built in the United Kingdom. Also, I think United Kingdom has several the gas cooled reactor using carbon dioxide. And I cannot see. Wait a minute. I cannot see bottom side. Okay. Okay, no problem. And I think the original high temperature gas cooled reactor from the German, and the post high temperature gas cooled reactor in German in the AVR, also, and the US we call the pitch bottom. this kind of high temperature gas reactor very old style, using concrete and something like that. However, and in 1980, and developed more advanced technology using the passive steel and the reactor vessel, and we call HTTR in Japan and HTGR-10. This two reactor is not commercial reactor, is a test reactor. So based on this technology, and China, Japan, and trying to develop more bigger high temperature gas cooled reactor. However, and in the Japan and the US, and did not deploy the big high temperature gas cooled reactor. However, and China, and finally China deployed the bigger high temperature gas cooled with the bigger power, such as HTR PM in Shantung and the Peninsula. So nowadays, and 2012, some in developed many countries developed the SMR, and USNC, US company, and Hyundai Engineering, they jointly and started to develop MMR in the since 2015. Some, and also other type, the HTGR, such as X-energy. X-energy technology, X-energy based on and the pebble type nuclear fuel, developed by the German. Also China use and the pebble type, pebble type fuel as their own and reactor, such as HTRPM. Please next. This slide should explain about the modular reactor. Some micro modular reactor developed by USNC, US company, also Hyundai Engineering, since 2015. The power of a micro modular MMR is about 15 megawatt thermal, also 5 megawatt electrics. And also the coolant and moderator is helium and graphite respectively. And the design life is 20 years. And the USNC Hyundai Engineering developed MMR, the post application as a post application for and provide electricity and mining in the northern area of the Canada. Is mining and in the northern area of Canada, so many mining. This kind of mining use electricity as a power about due to up to the 30 megawatt electric. So that's why, and Hyundai Engineering and the USNC and performed a kind of a feasibility study. Thinking about the Beijing module, power of Beijing module is the 5 megawatt electric. If mining customer ask a kind of 20 megawatt electric, we can provide 4 modules, and each module is 5 megawatt. Total power is about 20 megawatt electric. MMR and do not need refueling during 20 years. However, if we use and if you refuel a kind of every 10 years or every 7 years, in the case MMR can produce the more power, such as due to the 50 megawatt electric. Yeah, so there are many characteristics of safety and construction, the eco-friendly application. So this item I can explain the next slide. Please, next. This slide shows the short introduction about the Hyundai Engineering and the USNC. And Hyundai Engineering and established in the 1975. Now CEO Hong Hyun-sung, and headquarters located in Seoul, in South Korea. The number of employees in the 6,400, and the being the sector, including and plant division, and such as process and power nuclear, also building work division, and infra and environment. We are a technology area and project manager, and engineering and procurement, construction, marketing proposal, the asset management. And the USNC, established in the 2011. The current CEO is Francesco Benelli. The headquarters is Seattle in USNC. And the number of employees is about 200, is a kind of a startup. And the business sector is a nuclear system that developed based on the full captured fuel. Also, USNC have a factory and which can and manufacture and FCM. Also, USNC have so many and experts who can and design and the reactor of MMR. And also the technology area, the FCM pure, based on the high temperature gas cooled reactor. And also they can, and now they are developed nuclear thermal propulsion based on the high temperature gas cooled reactor. Let's please next. This is a history of developed the micro modular reactor. In the 2012, Hyundai Engineering and made the MOU, USNC, for developed high temperature gas cooled, also very high temperature gas cooled reactor with the Hyundai construction and the Hyundai heavy industry. And since 2015, and Hyundai Engineering and the USNC made the MOU and agreement for develop MMR. So the 2017, we finished the concept design of MMR, and the 2019, and we finished the basic design of the MMR. Also, we performed the vendor design review from the CNSC, we call the Canadian Nuclear Safety Commission. And also we are submit license to prepare the site for MMR Chalck River site. So 2020 and 2022, HEC and finished Ikuti invested in the USNC. Also we finished the contract, two contracts. One is engineering contract, the other is a procurement contract for MMR in Chalck River project. And next. This slide explain about the MMR, the system. And the MMR system consists of mainly three parts. The one is a nuclear part including and the nuclear reactor. And the nuclear reactor can produce the heat and by fission reaction of uranium and neutron. And also, and the Jason plant. Jason plant can produce the some electricity and some high temperature process heat, and also some distinct heating. And between and nuclear plant and the Jason plant, there is a kind of we call molten salt loop, the middle. The function of molten salt loop has main two function, and one is and molten salt loop has the function, the heat reservoir, and the other is molten salt loop is a protection radioactive material from a nuclear plant to the Jason. If accident occur in a nuclear plant, in the case the radioactive material released to the out of a nuclear plant. So, however, there is the middle, we call molten salt loop. So molten salt loop can store this kind of radioactive material. It means the protection. The public, we have a protection public from the radioactive material. Using this kind of loop. Also, this kind of loop has a function of heat reservoir. It means the hybrid. We can the computer. We can make a system hybrid between and the renewable energy such as solar energy, also the nuclear, the plant like MMR. In the daytime, the solar panel or solar concentrated solar power can produce the heat to the molten salt. In the night time, we don't use solar power. In the case, and the MMR can and heating also provide the heat to the molten salt. And if molten salt have keep and the very same temperature like 300 degrees C. In the case, always and using this high temperature molten salt reactor, we produce the electricity turbine, also produce the high temperature the process heat to the industrial application. And also MMR use FCM pure. FCM pure is called as a polyceramic micro encapsulate pure. And the FCM pure using the TRISO. And you can see and write a schematic diagram about explain of FCM pure. And the pure kernel made by uranium dioxide also, and the uranium dioxide size is 0 point, about 0.8 millimeters. Coated by three layer using material as a silicon carbide, the ceramic material. Also, and the TRISO, so many TRISO included in the we call and the pellet, and also pellet stack. Also, and in the pellet stack, and the pellet stack is entered into the graphite block, and also stack so many graphite block, and the core size, this core, located in the reactor. So this is MMR, the reactor. Some FCM pure is very safe, and even if in high temperature, such as and the 1800 degrees C. So it means if any severe accident happen, and the reactor core not melt, it means there is no severe accident, and severe accident occur. Okay, next slide, please. Yeah, this slide shows the MMR pure manufactured facility. There is a pilot pure manufacturing facility in the U.S., Oak Ridge near National Laboratory, and the right-hand side and this picture shows the opening ceremony. In August 22 this year, and at that time, and the very important people such as and the DOE Assistant Secretary, and also Tennessee Congressman and U.S. Executive Vice President. So yeah, and also left side some and some explain about the efficient fuel. The first triso fuel, and the triso fuel and the Solgel conversion and the particle coating, and through this kind of process we can manufacture. We can made triso particle. Also, this facility including the manufacture facility for making triso. And after that, the efficient pure pellet is made by 3D printing. I visited this facility. I show all process for manufacture efficient pure. Now there is no graphite manufacture facility. However, and in the future, and the USNC and have a facility can manufacture the graphite. Okay, next slide. This slide shows the Chalck River MMR project, and the Chalck River project is a kind of demonstration and project. It is the first MMR project in Canada. This project owner is Global Post Power in the Canadian company, and the equity of Global Post Power is 50% USNC and 50% OPG. OPG means the Ontario Power Generation. This Ontario Power Generation is a state company which can provide electricity in the Ontario state. And also we have a Canadian partner such as PCL as a construction company and Hatch as the engineer company. So yeah, this is capacity. This is the 5 megawatt and the Beijing module. The project period. I expect the commissioning of MMR will be finished in the 20 and the 26. So, and the main progress already I explained. And the MMR project data. I did explain also, and the primary and nuclear steam supply system, and helium and the pressure and the 30 bar. Also, and the core coolant temperature in the 630, and molten salt loop and the steam generator. So, and using the molten salt loop, and the loop, we have a limitation about the core outlet temperature due to the material molten salt loop. We can change the material molten salt loop. Under current technology, we can produce the more high temperature steam due to the 800 degrees C. So next, please. No. So can you the picture click? We can show the short video.
At every moment humanity is taking a leap, Hyundai Engineering is there. Hyundai Engineering has grown into a global engineering and construction company through successfully performing more than 5,000 projects worldwide. As a member of the Hyundai Motor Group, it continues its gleaming challenges based on the worldwide network of the group. Based on its capabilities, Hyundai Engineering is now transforming into a carbon-neutral energy company, carrying out projects for hydrogen production plants using waste plastics, clean hydrogen extraction.
Sorry,
The surface temperature of
I cannot say it.
since 1880 and causes climate change.
Oh, wait. I will show you again, maybe. Wait. Because.
Yeah, sorry for. So
yeah. Maybe I will say.
I am to operating myself.
Okay, wait. Can you see this YouTube?
Yeah, I can see. Good, perfect.
The moment humanity is taking a leap, Hyundai Engineering is there. Hyundai Engineering has grown into a global engineering and construction company through successfully performing more than 5,000 projects worldwide. As a member of the Hyundai Motor Group, it continues its gleaming challenges based on the worldwide network.
Yeah, it's like no voice, Pak Jarod.
Yeah, no voice. Something wrong. Okay, I send the I send the video file or a link to YouTube. Okay. I cannot hear you, Gerald. You mute.
Yeah, sorry with the trouble, because I don't know why I cannot give the audience with the audio. Okay, can we? Do you want to play again the movie or go back to the PowerPoint?
Yeah, go back to the printed material. So I send the link or the video of some. Yeah, you can see and MMR the video. Okay, next. Yeah, this slide shows the the ceremony about the USNHC engineering the contract, also USNHC and the procurement contract. So, and yeah, the USNHC now and work hard to meet a schedule MMR Chalck River project. Please next.
Okay.
This is a schedule for developing and demonstration schedule. So please please understand that this is the developing stage and the schedule. So and in case of commercial schedule, some very the much shortened, more shortened than this schedule. Some now and 2022. Some we are also submit and environment and assessment also submit to the license to site preparation. So I expect middle of next year we submit. We call the PSAR, preliminary safety analysis report for and the construction. Some and 1 year later, the 2024, some we are going to submit a final safety analysis report to the for a license for operation. So and the MMR is MMR designed by a module, it's 100%. It means the construction MMR is very much shorter than the big power plant. So the reason is that the MMR designed by 100% module is the post application to the already as I explained in the northern area, northern territory of Canada, very cold. So also and the period during 1 year is the possible construction the period is less than 5 months and 6 months. So that's why and we are design 100% design the module. It means the and very short construction period in the site. Already we are manufacture in shop 100% manufacture the module, and inside already we are assemble the module, not the stick type. Some assemble module is this kind of technology can and reduce and construction period in the site in less than and almost 6 months, including the site preparation. So we expect to finish the commissioning in the 20 and the 26. I understand that this is a very aggressive schedule. So, however, you know this and the Korea construction technology of power is very strong. So I push my team to meet this kind of schedule. Please next. Yeah, this schedule is a commercial MMR project schedule, and this kind of schedule based on the some commercial mean the already we have experienced licensing post reactor from the second reactor. There is no technical issue for licensing process. That's why we can reduce the licensing process. It's mean we can expect this kind of MMR project schedule. The MMR is a very small plant, also made by the 100% module. Some already in the basic design, and if this kind of design, the schedule, the after contract, we finished MMR construction and installation, the commissioning, within the 3 years. Okay, next please. Also now, the Hyundai Engineering, and now we are considered not conclusive remark. This is, and we are developing a supercritical CO2 cycle. We are using the supercritical CO2 cycle and produce the more economic price for the MMR, because and this is left side, the propellant is for steam cycle current design. However, using a supercritical CO2 cycle and very small, very small propellant, also very and small number and the module is means about less than 20% of the steam cycle propellant. Some very and using and the supercritical CO2 cycle, the MMR to become the more economic plant. And also we are developing and hydrogen production technology using MMR. Also we call and high temperature and electrolysis technology. We call the solid oxide electrolysis cell. We call it SOEC. Also we provide the high temperature heat for application of industrial heat supply. Next, please. Yeah, this is a concluding remark. And MMR is a fourth generation nuclear reactor in demonstrate in the Western world. Also, HEC and the USNC will the proceeding with the global commercialized through the MMR Chalck River demonstration. Also, HEC welcome the Indonesian nuclear industry society and in developing of multi-module, multi-purpose MMR, such as hydrogen production and the supercritical CO2 cycle, and developing high power MMR system, also industrial heat supply. And thank you very much for your listening.
Okay, thank you very much, Dr. Lee. It's very impressive one, because you said that it takes only 3 years.
Yeah.
Yeah, it's very fast comparing with the many nuclear power plant projects. Maybe it takes 10 years or maybe more than that. Are you optimistic that you can go smoothly with this project?
Yeah, it's a kind of commercial case.
Okay.
Not a demonstration.
Well, okay. My question is about this joint work between the Hyundai Engineering Company Limited with the Ultra-Safe Nuclear Cooperation. So I read in your slide that the Ultra-Safe, the American company Ultra-Safe Nuclear Cooperation doing the maybe some design, and then EPC is doing by the Hyundai Engineering Company Limited. And the other things that how many years it takes to get the permission, the license from maybe from Canada or from the United States or from the South Korea regulatory agency? How many years for this design?
Yeah. Already I explained the schedule in the demonstration project in Canada.
Mm-hmm.
Yeah, and I think some already we already start environment assessment and license site preparation. And I think the main licensing process we call about license to constructions. I think the next mid of next year we are going to the summit PSAR to the and CNSC is a kind of from the and in case of demonstration we expect main and the licensing process it takes about 3 years.
Okay. Well,
already we get the VDR phase 1 vendor design review performed by CNSC. It's a vendor design review, a kind of pre-licensing and the review, something like that. So the conclusion of a vendor design review MMR is that CNSC the licensing can do licensing review for MMR technology.
Okay, yeah. The other questions that usually coming from the decision maker of Indonesia or the government about the cost. Sorry to ask you, with that kind of project, the demo project in Chalck River, Canada, how much the cost for this 15 megawatt MMR?
In the 15 megawatt summer.
Yeah.
Yeah, you know, the demonstration, the plant is and more expensive than the commercial.
Sure.
Yeah. So it's you know, this including some including demonstration and the budget is about almost I can say is about including construction is about 200 million
US.
US.
Oh yeah. Oh yeah.
Including,
I think it's very
including and you know the research and the demonstrations or something like that. However, I expect and one unit of 15 megawatt summer of a commercial case. Some commercial means is 3 or 4. The third and fourth, the MMR is less than the $100 million, something like that.
Okay, I will explain in Indonesian language first. Bapak Ibu sekalian, ini menarik sekali bahwasanya Hyundai mengatakan bahwa secara komersial ini kalau untuk produk komersialnya bisa cepat 3 tahun pembangunannya. Ini sesuatu yang menarik. Juga tadi disampaikan bahwa untuk proyek yang dengan Kanada ini biayanya mungkin kalau 200 juta US dollar itu sekarang berapa? Karena sudah di atas 15, berarti sekitar 3 triliun rupiah ya. Jadi untuk 15 megawatt thermal atau sekitar 5 megawatt elektrik. Ini menarik, waktu itu kita dengan RDE, mungkin teman-teman yang di ekspatan tahu, RDE itu ketika di pihak Rusia menawarkan sekitar 4,3 triliun atau waktu itu 300-an juta US dollar. I talked to our audience in Indonesian language that previously we had the experimental power reactors program, RDE, and we have a contract with the consortium of Germany and Indonesian cooperation. They offering us the project with 300 million US dollars. So this Hyundai's demo plan is much cheaper than what we did in the past. But RDE project is halted or delayed. Maybe someday we will continue with this kind of the same technology is DCR. So anyone, if you want to ask the question directly, please raise your hand. Silakan angkat tangan saja atau saya bacakan, or I will read from the chat. This is a first question from Mr. Samuel. If Mr. Samuel want to ask directly to Dr. Lee, it is okay. If not, I will read it. Mr. Samuel asks you, Dr. Lee, how about the environment impact to to operate that nuclear reactor system? Is there any analysis about the environment impact on this, for example, Chalck River demo project?
Yeah, the environment, the work of environment assessment, including some analyze the impact on environment also, and the hearing in the public and the near and the plant. So yeah, so also in Canada, there are many we call the First Nation, indigenous people, you know, Indian people. Yeah, so we have to get the approval from the we call First Nation indigenous people. So and yeah, I think we already and we already opened many and public hearing, the committee in the Chalck River. Also, you know, that in Chalck River site, the MMR located in the parking lot of inside the Chalck River National Laboratory. The Chalck River National Laboratory is the first nuclear laboratory in Canada. You know, already and the Chalck River site licensed by and the CNSC for the nuclear facility in the site. Also, you know, the MMR use and the triso pure as a nuclear fuel, and so many, and there are so many evidence that this triso pure in accident case do not release any radium material from outside of and the triso pure. That's why. And I think my personal, I am a nuclear engineer. So I think there is no impact on the environment of the MMR the plant. That's why MMR plant can locate near industry and factory also, and near located in the city. Your city can produce the steam and the electricity.
Okay, oh, this is very interesting. Then you say that even this MMR can be located inside the city or near the industrial location. So it's mean you don't have to locate the MMR in the isolated area or something like that. This is very interesting. Yeah, and it is also interesting, even this project is located inside the laboratory area, but you still have to have a public hearing with the local people over there.
Yes.
With the Indian people. Okay. Moga-moga Pak Samuel sudah bisa terjawab ya pertanyaannya masalah environment impact ya. And then this is the second question from Mr. Haryono Santoso. If Mr. Haryono Santoso want to ask Dr. Lee directly, we are welcome. But if not, I will read your questions. Thank you for your presentation, Dr. Lee. Please let me know first, how does the MMR to protect the environment from the hazard of several accident? I think the same question with the previous question. The second, does the design of MMR develop any limit for radioactive release to the severe accident? And the third question, if there is any release limit, how does the design ensure that the effectiveness is okay? Thank you. This is the third question about the design to ensure the effectiveness to avoid any release of the radioactivity.
So pardon me?
The second question is, does the design of MMR develop any limit for radioactive release due to the severe accident? This is I think the first question is the same with the previous question. And the third question, the last question from Mr. Haryono, if there is any release limit, how does the design ensure the effectiveness of the system?
You mean the question is about some release radioactive material?
Yeah.
From
In your design, is there any a consideration if there is any release of radioactivity? How do you do with the system to control that, or maybe is there any limitation of the radioactivity release from of that design?
Yeah, we have some. I think. Sorry. Okay. I think there are kind of law. Each country, a kind of nuclear law. Each country about a limitation of release radioactive materials in case of that accident. And some, however, the MMR I think as I told again, and MMR use TRISO pure, and is a TRISO first developed by the German, also in the US, and US and many the laboratory such as Idaho laboratory, Oak Ridge laboratory performed many kind of experiment about the TRISO pure. Some in the TRISO pure the experimental scientist transferred into the test reactor with the high neutron flux. Some and some the investigation after we call the exposure neutron to the TRISO scientists and research the impact of TRISO with the exposure high neutron flux. Some there is no and leakage. There is no and some leakage from the TRISO pure. Some that's why it's USNC USNC manufacture USNC technology about the manufacture TRISO pure have has many and so many years the study and have validated by the experiment data using the US test reactor.
Okay, so Pak Haryono, I will explain a little bit in Indonesian language. Pak Dr. Lee tadi menjelaskan bahwa kemungkinannya sangat kecil dan mereka mungkin perlu kami jelaskan bahwa teknologi ini adalah high temperature gas cooled reactor menggunakan fuelnya bentuknya bola-bola tadi Pak Dr. Lee selalu mengungkapkan bahan bakar TRISO itu bentuk bola-bola, jadi dan itu sangat kuat tangguh selama ini dalam perjalanan eksperimen yang dilakukan baik di Jerman maupun di Amerika kemungkinan sangat kecil atau bahkan tidak pernah ditemukan kemungkinan terjadinya suatu radioactivity release dari bahan bakar tersebut. Jadi kebetulan juga ini generasi keempat jauh lebih aman, selamat, karena safety dan security bahasa Indonesia itu aman. Itu salah satu kelebihan dari generasi keempat PLTN. So there is another questions. Maybe this questions about I will interpret the question is whether you will also build this kind of technology in Korea.
Yes.
Some days.
Yes, someday. So
okay.
I think after finish the demonstration project in Canada.
Mm-hmm.
Also, and also we have so many other countries like the Poland, some other countries, some ask and collaboration MMR development their country also, and I trying to introduce the MMR in Korea to produce the hydrogen.
Oh, okay.
Yeah, not the it's a first stage, the R&D stage. And after that, I would like to increase the power of MMR to the 100 megawatt summer. Yes,
So according to the current national energy policy, how many percentage of the energy is coming from the nuclear energy, let's say in 2030, for example? How many percent? Well, his question is maybe because you talk about after the demo plan in Canada, maybe you want to build this kind of technology in South Korea.
Oh yeah.
Is that it? Then his question is, how about the energy mix in South Korea? Is there any projection how many percentage at the moment in the current status? And then, for example, 10 years from now, how many percentage the energy is coming from the nuclear? Is there any policy in your country, in your government?
Yeah. Current the present, this new president fully support the nuclear. Also, and there are many the nuclear research program for the not electric application. It means the application to the produce hydrogen, application to the industrial application for the chemical plant, something like that. So, and in Korea, we call the most Minister of Science and Technology have a program for develop this kind of technology using and high temperature gas coolerator like the MMR. So, and I hope I hope soon this kind of research program will be a start. Also, okay. I hope collaboration Indonesia and each country the application.
Okay. Well, the current situation right now, around 29% or almost 30% is coming from the nuclear energy, isn't it, in South Korea? It's very significant percentage. So I would like to ask Dr. Dandang to ask directly. Please, Pak Dandang, if you have any questions, because you are the expert of the SDGR also.
Who is
okay, thank you, Dr. Jarod. What I will ask to you is about the design life, is to short design life of the MMR that is 20 years. So it if we calculate that the 5 megawatt electric with the 200 million, and we can get is to short the lifetime of the reactor. So it will become the not good impact to the economic factor. Is how please explain this, because it's begini Pak Jar, 4 triliun hanya dapat 5 megawatt, padahal 40 triliun dapat 1000 megawatt gitu. Umurnya juga 60 tahun gitu. Yes, okay.
I think Dr. Dandang asked you about the lifetime of the MMR, only 20 years. Well, usually in the nuclear power plant, maybe more than 40 or 60, even more than that. So his question is, well, is it economically possible, or is it good for the economy? For example, is it not too expensive because 20 years?
I understand that kind of question, because is there is some the economic aspect of MMR, also the SMR, is may not good and compared to the large water reactor. You know, however, and already I explained the MMR, originally MMR developed for application to the northern area, mining place of northern area of Canada. So, and also MMR can apply the remote area such as island, also some the desert, some remote area. Some and I mean that kind of number which I already spoke to is not it's not exact number. I approximately say that kind of the number. Some and Hyundai Engineering USNC, and we have built and module factory and the massive production of the module factory using because the MMR or SMR not compete compared with large water reactor. So we are thinking about the new technology, new construction technology, not the stick built. Already we have produced so many so many reactor, so many module before the order. Some after we get the order, so we are provide this kind of material, the module and the reactor to the customer, and also very short and storage period. So I explained that kind of technology can and meet and economic scale of the MMR or SMR.
Okay. Yeah. Can I add? Maybe because this is demo plan, maybe because this is first of a kind. So yeah. You choose this short period, but it is possible. But I don't know whether to extend later on the lifetime of this MMR. Is it possible?
Yeah.
Okay.
So one more question. So if
please,
to extend the life of the system, except maybe the fuel can be replaced, refueling with new fuel after 20 years is okay.
Yeah, we can extend.
System is still used until maybe 40 or 60 years.
Yeah, no problem.
Okay. Understand.
Yeah, is there any question?
Depend of customer. Depend of customer require. Customer request, we can and produce the the 40 and 60 years MMR, using the change the fuel.
Yeah.
Okay. Is there any questions, Pak Tanda?
Let the another person.
Okay.
Thank you.
Thank you, Pak Tanda.
Thank you for question.
Yeah. There is another questions from Miss Citra. I think Miss Citra is. Do you want to ask directly to Dr. Lee, or I will translate into English? She asked about how much the cost of production per kilowatt hours this MMR. And the second question is, how can, for example, after the operation or even after you build in another place in Poland or maybe in South Korea, how can you assure to get this fuel supply? From where? This is very important because we have to make this kind of reactors sustainable. From where the fuel is coming, or it depends on the as you show us in the presentation the plan that already started to produce the fuel? This is the second.
Yeah.
The first question is about the cost of production.
You mean the MMR, cost of MMR?
Yes, cost of production per kilowatt hours. Her questions.
Yeah. I think it is hard to say.
Yeah, because still under.
It is just a demonstration stage. Yeah, we are investigation that in case of commercial, using the new technology for the pure manufacture, the reactor manufacture module, and based on this technology, we can reduce the liquid cost of MMR to the customer the level, something like that.
Okay. Yeah.
And also, I think electricity also we can use MMR as other application in hydrogen, also heat supply. The price the hydrogen heat supply, I think more economical than the produce the electricity.
Yeah. Okay. So this is very interesting also, because usually the people in Indonesia, especially who work for the government, they always ask too early, but their question is how much the cost of production, for example, per kilowatt hours. This is too early because you said this is the demo plan. And the second question is about how can we get the fuel? Is there we have to depend on the factory in the MMR factory that you have already explained? But I think it's rational that we have to use that kind of factory. When we conduct the RD program in the past, we have already communicated, for example, with the Chinese, the CNNC, how can we get the supply of the fuel at that time? Okay.
Yeah. Also, is already we finished the build of the pilot sketch. Just the pilot is not the same technology with the commercial pure the factory. This pilot means it's just one line. We can add the more line to the commercial scale. I think also we consider that this kind of factory will be built in the Korea. Yes. In the case, but if Indonesia want to build MMR, Korea can produce pure to the Indonesia. Also, I think Indonesia can build this kind of pure factory. This MMR, the MMR pure is a basic component is pellet. The pellet is like this, very small. It means the scale of a factory is very small.
Okay. Yeah. I think you have already answered all of the questions. If we want to build the fuel, the MMR here, maybe someday, the plant or the fuel fabrications in Indonesia also. But it depends on the how many numbers of MMR.
Yeah. I understand that. Yeah.
Okay. And another question from Listia Prabowo, Mr. Listia Prabowo. Dr. Lee, as I know, helium is a rare gas. It's very rare and sometimes lack in the market. So is it safe to use it for now? Or how can you get the helium from the market? Is it easily available?
Yeah. So helium gas we can buy everywhere.
Okay.
Yeah, we can buy everywhere. You know the balloon. Yeah. When you make a balloon, you know balloon?
Yeah.
When you make balloon, we can use helium gas injection the balloon. Yeah, expand very cheaper. Very common material.
Okay. There is one expert, Indonesian expert also, Pak Ari Nugroho. Do you want to ask directly to Dr. Lee? Please, Pak Ari Nugroho.
Yeah, thank you, Mr. Jarod. I try to deliver the question by myself. To Dr. Ali, thank you for your interesting presentation. Actually, I have two questions for you. The first one is, does MMR should always be coupled with adjacent plant, such as molten salt system? Could be standalone and only designed for producing electricity? And the second one is, instead of using MMR to generate 5 megawatt electric, why don't we use SMR STGR technology and manipulate the reactor to produce that output? Thank you very much. That's all my two questions.
Yeah, so the Dr. Jarod, please.
Okay,
explain.
the first question is, does MMR should always be coupled with adjacent plant?
Yes.
Yeah, such as molten salt reactor.
Yeah.
Could be standalone, could be just only standalone, and only designed for producing electricity only, not for another purpose, not for the hydrogen production, for example.
And let me
give
the question, the correction of my question. Not instead of molten salt reactor, it should be molten salt system, not molten salt reactor.
Oh, molten salt system.
Yeah. So I think this is just a demonstration, one unit, you know. This is just a demonstration. That's why one unit. Some if and we built more units, more power. In the case, you know, this reactor plant is not changed. However, the adjacent plant should be changed. Some the steam turbine, more big on the steam turbine. So, and the purpose of this demonstration, the plan is about validated nuclear design, something like that. Yeah, and adjacent plant should be changed and application, depend on application such as produce hydrogen and electricity and steam produced to the industrial. It's very common technology. However, and the reactor technology is a new technology. That's why, and the demonstration, the plant is used to the validated and the reactor technology.
Maybe the second question is, maybe I don't know how to interpret your question, Pak Ari, because Pak Ari Nugroho asked you about, instead of using MMR to generate 5 megawatt electricity, why don't we just use the SMR STGR technology?
Yeah. Okay. Yeah. Okay. So
we can manipulate the reactor to produce 5 megawatt electricity.
Yeah. Already I explained. You know, this 100 megawatt SMR is needed. For demonstration, it's needed large and big money, you know, almost 1,000 billion dollars, something like that. However, I choose MMR technology is a kind of this demonstration using this technology. We can increase the power, you know. Also there is so many and market to micro reactor. So remote area, remote mining, and also chemical plant. Chemical plant need a high temperature steam, and the chemical plant at not much and the power. So already they need high temperature steam. So that's why Hyundai Engineering choose MMR technology as a kind of the first step for the SMR, the market, the entry, something like that.
Okay. Is there any questions, Pak Ari?
I think it's quite understand.
Okay. Thank you. Thank you, Pak Ari. There is another question. This is Indonesian unique questions. The license or permit to build nuclear reactor in Indonesia is way longer, maybe longer than 2 or 3 years. It will take at least 5 years, assuming no internal nor external issue. How about your opinion on that? In case of the Chalck River, I see that the site is already there. Then maybe it doesn't need site permit or site licensing.
Yeah, we need a site license. However, you know, the Chalck River is a nuclear laboratory. Yeah, so inside the Chalck River, there are so many small reactor. Now it's decommissioning. So that's why, and the Chalck River is very suitable site for demonstration plant. So yeah, I understand that. However, you know, and I understand in Indonesia, I think there is no nuclear power plant in Indonesia, right?
Yeah.
So, and in case, I think, and the country which introduced the post nuclear power plant is, I think it is a better idea that and adapt this kind of very micro module, very small reactor. However, you know, the power post reactor is about 1,000 megawatt electricity, something like that. It needs huge money, you know. Huge money. So, and this is MMR. This is also the demonstration cost. The MMR is about you know, is about 1,000.
Okay.
Less than sometimes less than some number. So you can easy adapt this kind of technology also. And if you do not start, and if you do not start R&D this kind of reactor, so you know the 20 and 13 in some time is, I think, and will be late, I think.
Yeah, I think well, we have already experienced on how to shortening the licensing in Indonesia. For example, if this MMR is already get licensed from a regulatory agency from the Canada or from United States or from South Korea, so our regulatory agency also can learn from them and adopt that kind of licensing in Indonesia, rather, for example, from zero, for example. So it will shortening the time because already there in Canada, for example. And if it is in operation, it is much easier also because you can say, oh, this is proven technology. That's already in operation in a country like Canada or maybe in United States or in South Korea. So this is originally a question from Dr. Dandang. Dr. Dandang asked, if, for example, you want to build in Indonesia, is there the cooperation between the Hyundai Engineering Company Limited and also the Ultrasafe Nuclear Cooperation still exists, or you will be independent companies to construct the NPP outside Canada or outside Korea?
We have some, you know, this we have a Hyundai Engineering kind of exclusivity EPC for MMR. So USNC can provide nuclear fuel, you know, also provide some the design of a nuclear reactor. So Hyundai Engineering can procure and the nuclear reactor based on the USNC technology. Also, you know, there are many business Hyundai Engineering in Indonesia. Also, Indonesia, Hyundai Engineering can, and collaboration with the local company, also local, and also Indonesia nuclear research, something like that. Is I think it's very important and localization of this kind of technology.
Okay. Well, this is very interesting. It means that there will be another collaboration between the Engineering Corporation and US Ultra-Safe Nuclear Corporation, and maybe the local companies. Okay.
I think during the 2020 decade is a kind of and the demonstration, the stage of SMR. You know, so many. There are so many SMR and which underdeveloped. They need a demonstration during the decade of 2020. You know, in 2020 we have some. And I expect and MMR is needed demonstration and verification stage. So after we overcome that kind of technical hurdle, so we enter the market as a commercial version of MMR.
Okay. This is my last questions. Maybe if audience have another one. Usually the nuclear power projects, although, for example, the construction's only 3 years or 4 years, but it delays by many factors. Do you optimistic that this demo plan will be on time in 2026? You will commission this reactor?
Yeah.
Okay.
You know, because compare please compare the MMR and the current large nuclear power plant. You know, the large light water power plant has and a very big concrete structure. We call the reactor building or contained building, something like that. And also, so many building so many something like that. However, you know, the MMR consists of the current MMR, the version is consists of eight module, just 8 module. Yes, this kind of module and manufacture by the shop and moving to the site just and assemble. And also there is no big containment structure in the MMR. Just because and the MMR don't need this kind of structure because there is no release from the radioactive material during the accident also and the normal condition. However, and you know, the APR 1400 and mean the Korea, KHMP Korea, and being right order reactor. In the normal operation, there is some number of radioactive material released from the reactor. That's why we need this kind of big and concrete material. However, there is no this kind of structure in MMR, just module. That's it.
Okay, well, that's very good because very impressive one in 3 years. It means that this year or maybe next year you will have a groundbreaking.
Yeah. Next year we will provide PSAR for the construction. Yeah, so and I think it's important thing is licensing. You know, the licensing is may takes a longer time. However, and after get the licensing, there is no hurdle. This is just the module assembling and something like that.
Okay, thank you very much. I have to explain in lesson language. Bapak Ibu sekalian, ini impresif sekali. Dari sisi pembangunan juga relatif cepat kalau melihat timetable-nya tadi 3 tahun begitu ya. kemudian juga pembiayaannya ya memang karena ini sebagai suatu demo project tidak bisa dibandingkan dengan PLTN besar misalnya. Tapi kemungkinan kalau nanti sudah produksi ke sekian kali bisa jadi akan menjadi lebih turun lagi. Jadi tidak bisa dibandingkan, tadi kan ada pertanyaan masalah cost of production atau biaya pokok produksi misalnya. Tadi kan ada Mbak Citra atau siapa yang bertanya. Nah, ini menjadi catatan, apalagi ini punya kelebihan di mana suhunya tinggi, bisa menghasilkan produksi hidrogen sesuai dengan pemerintah Indonesia kan ingin ada suatu alternatif terkait energi dari hidrogen. I think it's very important because you saw us about the possibility to use this kind of technology for the hydrogen production. Because some of the state-owned company, they are considering to use nuclear for their future hydrogen production. This is very important to use the high temperature gas-cooled reactor. Anyway, for the closing remarks, I want you, Dr. Lee, to say something that very optimistic, or maybe you ask us to have a collaboration or something like that. Please, Dr. Lee.
Yeah. Okay. So yeah, thank you for hearing my presentation. So I have a poor English. So yeah. And I would like to make proposals that I can visit Indonesia for more the face meeting about develop Indonesia the MMR version, also the develop and other application using the hydrogen and produce the technology and something like that. So and I welcome to invite me in Indonesia for discuss the technical issue. Thank you for hearing my presentation.
Okay, thank you very much, Dr. Lee. I would like to share this information to our stakeholders in Indonesia. Hopefully somebody or the government interest this kind of technology, because this is very impressive one, especially for Indonesia that condition is archipelago country. There are many small islands, for example. And again, hopefully we will, have a good communication after this.
Yes.
And hopefully there will be a cooperation between Indonesia, Hyundai, and Hyundai Engineering Corporation. Thank you very much, Dr. Lee. And again, I would like to apologize that there was some trouble.
There's no problem. It's my fault.
Again, thank you very much. Thank you.
Thank you.
Yeah.
Thank you. Bye-bye.
Thank you. Bye.
Thank you.
Terima kasih Bapak Ibu sekalian, demikian pertemuan kita hari ini. Minggu depan kita ketemu Kamis lagi, dan terima kasih. Thank you very much for all of the audience and for all of the questions. Thank you. Terima kasih. Bye.
Thank you. Bye.
Terima kasih.
Bye. Assalamualaikum.
Waalaikumsalam. Thank you. So I would like to close the Zoom. See you next Thursday.
Assalamualaikum.
Waalaikumsalam Pak Isra, nggak nanya tadi.
Terima kasih Pak. Nyimak